All right, my name is Sara DeLaurentis. I am a second-year master's student, and I am working on a project with examining earthworm impacts on the northern forest floor. We begin with the humble earthworm. So innocent looking and small, perhaps it is insignificant to biological processes. The opposite is actually true. Earthworms are very capable of modifying their environment. Many species of earthworms are considered geoengineering species because they are very effective at consuming, reorganizing organic material and mineral soil. So I'm going to tell you a little story here. Earthworms are not native to Minnesota. Anyone who's lived here for a little while may think that they are native here because you might have grown up fishing, using them as baits, or seeing them in the garden or in the fields. They are not native here. So there was this thing called the last glacial maximum, and these glaciers came down and they covered much of the North American continent, effectively killing off all the earthworms in that area. And earthworms are not good at moving themselves. They have no legs. Even something as simple as a thin stream can stop them from advancing across the landscape. Enter humanity. Most of the earthworms we now find in Minnesota area are from Southern Europe, actually. They're native to Southern Europe, and they came across with European immigrants. In ship ballast, so you'd fill your ship with soil to weigh it down, then you'd sail across the ocean and then dump it on the shore. And so we got a lot of earthworms that way, and then through transfer of plant materials as well. So the interesting thing is that our forests have developed here in Minnesota without the presence of these geoengineering earthworms. So if you walk through a deciduous forest, you will, underneath your feet, this is what you might find if you were to, dig up a chunk of soil. You'll notice it's these organic layers of material that has been just deposited, from leaf fall, and it hasn't really been mixed in much by anything, because without earthworms, there's little to no bioturbation that occurs. So when earthworms come in, if they can actually remove this layer within a few years if you have the right types present. And so this is actually a picture from Adrian Wackett, who did some research in Sweden in some deciduous forests there. So pre-invasion, you see we have this OI, this fibric layer of organic material, not super decomposed, and then a hemic layer of more decomposed material. And underneath that is the mineral soil, this BW horizon here, that is not very well developed. There's not really much color development. You'd maybe expect that soil to be darkened by the organic material, but it's not. There's really often abrupt horizon boundaries here. So when earthworms come in, they start churning things up a bit or a lot. And you'll see here, this is in like the same type of forest here where earthworms have invaded. The organic horizons are gone, completely gone. And all that organic material has been mixed into the mineral soil to form an organic enriched A horizon. So the interesting thing about this that I'm studying is that complete removal of the insulating organic layer from the top of the mineral soil. So an interesting little note about kind of earthworm ecological groups. Not all earthworms are the same. So we have these like 4 major ecological groups. We have these epigeic earthworms that are often smaller. They kind of swim through the organic material. They're a little more benign, because they're not as big of geoengineering species. And then we have, we'll switch to the endogeic here, that kind of, they go more through mineral soil, and then they will also be present in this, next stage when it's all kind of mixed together. And the endogeic species are very effective at mixing together organic and mineral soil. And then we have our anisic species, which the most popular one here is Lumbricus terrestris, or the nightcrawler. They form these deep vertical burrows that bring organic material down into the subsoil and bring subsoil up to the surface. They also are very effective at removing the last bits of leaf litter from the soil surface. So if you see a bare forest floor completely void of organic material, you can bet that lumbricus is present because it's been pulling all the leaves and twigs into its home to eat them. Okay, what just happened here? Okay, so the questions that we set out to address. We want to know what the temperature looks like now that this insulating organic matter has been removed. What effect does earthworm invasion have on soil temperature in northern temperate deciduous and coniferous forests? So northern temperate forests, both deciduous and coniferous forest types. Question 2, does removal of organic material from the forest floor by earthworms have a greater impact on deciduous forests versus coniferous forests? So our treatments looked like this. We did some low invasion intensity in deciduous forests, low invasion coniferous, high invasion deciduous, low invasion coniferous. Oops, I might have read that wrong. I apologize. So our sites were located around Itasca State Park. That was an interesting story. We were trying to do in the park. We didn't get our permit. So we had to find land in Clearwater County that had similar sites. So this is just a brief overlook. You can see Itasca State Park is right about here. All right. And here is the work that we did in those sites. So we installed temperature sensors, eye buttons, and we installed at the soil surface. We installed underneath the organic layer if it was present, then 10 centimeters below the soil surface, and 30 centimeters below the soil surface, and then 50. Yeah. Okay, so here's a picture of that. That's a little cleaner and not in the field. So at the organic mineral interface, 10 centimeters below the mineral soil, 30, 50. Okay. Okay, and here is some data that we collected. I apologize, my data analysis is still in its earlier than I'd like stages. So here's a beautiful temperature series for you. So this is a low invasion deciduous plot here, and I will kind of walk you through these plots here. So here's a low invasion on top and a high invasion site. So the low invasion site has several centimeters of organic material sitting on top of the soil, and then the high invasion site has nothing. It is bare mineral soil. So what's really interesting about this figure here is that, so we have the air temperature sensor in black, and then the litter surface in orange. So in both of these here. And then what's really interesting is when you see the mineral soil surface in the low invasion, the amplitude of this wave compared to, you know, the one down here is quite different. As well as you can see the 10 centimeters below the mineral soil surface in blue here. You can see the amplitude is quite a bit decreased when you, I mean, it kind of makes sense, right? When you cover something and insulate from your diurnal temperature fluctuations in the air temperature, obviously there's going to be quite an effect there, but we simply set out to measure it, and we hope to publish this data. So that is what we have found so far in deciduous forests. And then, oh, okay, that was not planned. All right, well, I am done here. So I apologize, I wish I was a bit more prepared for this, but I would just like to say thank you to everyone. And I would like to acknowledge my committee members, my advisor, Dr. Kyung-Soo Yu, Lee Freilich, Tracy Twine, and Shui Feng. And Itasca Biological Research Station, they are wonderful people up there, highly recommend making a visit. And this Department of Soil, Water, and Climate has been absolutely phenomenally supportive to me as a graduate student. So, and our undergraduate researcher, Holly Frankart. So thank you very much.
Thank you, Sarah. Does anyone have a question? Please unmute your mic and speak out or type your question in the chat box.
Sarah, how long ago was that last glaciation?
About 10,000 years ago. So our forests have been developing without earthworms for about that long.
Thank you.